Hi, everyone, and welcome to PyData Global. We are excited to have you join us. Feel free to use the chat to connect with fellow attendees and share your thoughts during the session. And if you have any questions, please post them in the Q&A tab, and we will address them. But now it's my pleasure to introduce John Sandall. He will be presenting his tutorial, Fairness Tales, How to Measure and Mitigate Unfair Bias in Machine Learning Models. John is the CEO and principal data scientist at Coefficient, but as well as one of the chairs of the PyData London chapter. I've had the pleasure to know John for many years now working on that. And so please, let's give John a warm welcome.
Thank you very much, everybody. Oh, look at that. I love the emoji. Keep them coming. And also, I'm really keen to ensure that we get a bit of interactivity in here. So do ask questions in the chat. I can see that there. And feel free to also ask questions in the Q&A, however you like. So we'll be leaving some time at the end to answer them all. I may even answer them as we go. So do say hello. I want to meet you. So welcome to this workshop. This is Fairness Tales. This is actually the name that we've given to a project that I've been involved with for a good 6 months now. And there's some logos along the bottom here because these are our wonderful benefactors, the UK government, the Department of Science, Innovation and Technology, specifically the Responsible Technology Adoption Unit, Innovate UK, has funded us to investigate methods and techniques available for investigating fairness and measuring fairness or unfair bias specifically, because fairness and bias are two different things, and we'll get into that shortly. And what can be done in a world of very rapid evolving, not just machine learning, but AI and LLMs as well. And we'll be getting into all of that in this workshop. So do prepare your notebooks. There is a link. Thank you. I've just had someone mention, is it working? I'll make sure that that's working. It may have been still set to be private because this is a brand new workshop just for today. So bear with me there. I'll just make sure that's open. So some of the insights from our work with the UK government, they're not available today. They're under embargo for at least a few more months. However, we can tell you a lot about how we're doing some of what we're doing. And you can get a sense of what to look out for as we continue to find out some pretty juicy stuff around where LLMs are maybe falling short of what we'd expect the most powerful technology to be doing when it comes to ethics and fairness. And hopefully that link is now public for everybody. Do flag in the chat if not. So a little bit about myself. I am the CEO of Coefficient. So we are a AI consultancy based in the UK. I am also, as Jim mentioned, one of the co-organizers for the PyData London meetup. So hello to those of you who are dialing in from London or the UK who couldn't make it to tonight's Christmas meetup. Although if you are in London, I will be going to the meetup afterwards. So maybe see you in the bar in just a few hours' time. So as mentioned, we were awarded this funding from the UK government, and this is such an important thing for society. There are similar investigations happening in many sort of public sector work in different countries in the US and in the UK. So there might be a British slant to some of what we're talking about tonight, but it will be incredibly relevant for the US and other jurisdictions as well. The fundamentals of fairness are quite common across jurisdictions, although the specific legality of what might be constituted legally unfair or not is different from jurisdiction to jurisdiction. And so this is something that we know many regulators are interested in. So if you have got the ear of your local country's regulators, then hopefully this session is going to help you understand how best to advise them, because they're not as technical as we are, and we can really, really help them with the very, very rapid moving pace of technology and AI. So we're going to kick off with a little bit of history of AI fairness. In fact, there's going to be a very specific focus throughout the entire session today on one specific realm of fairness, which is in recruitment. Hiring is an area that has been classed by the EU's AI Act as one of the higher harm areas. So just below things like loans and credit scoring. But hiring has the potential for massive, massive productivity benefits from AI, and yet huge harms as well. If we've got AI systems that are being used by recruiters and teams internally, and they're being used to help justify what your future salary might be, but they've got very, very embedded skews in terms of what they might give you based on your, in the UK, we call them protected characteristics. In the US, it's things like ethnicity, race, gender, and so on. And these are things that you cannot change about yourself. And so if your next salary is contingent upon the color of your skin, that might be illegal in your country. In many countries, that's very much illegal. If your chance of getting a job is contingent on whether you're a man or a woman, again, these things generally, there are laws against them. And yet AI is embedding some of that today, as we'll see. So, motivating statistic, 72% of CVs are never seen by human eyes. This is a wonderful quote from Cathy O'Neill. If you're looking for good resources, if you're looking for an amazing Christmas present for the data adjacent friends and family in your life, then Weapons of Mass Destruction, it's an oldie, but it's a goodie, and it could never be more timely than it is now. So we already are living in a world where CVs are being analyzed by machines. Maybe some of you attending today are coding up those machines. They're probably coded in Python. And some of them use machine learning. Some of them are just doing skill matching with regex. And some of them are using LLMs today. And if that's the volume that is never being seen by human eyes, we better ensure that there is some sort of level of fairness guarantees in those systems. But how? This is actually kind of hard. And as we'll see in this session, there is a lot to think about. And I honestly don't feel bad for anyone who comes to this and just thinks, this is hard. Like, there is so much more complexity and nuance. And I just want to do data science or machine learning. I just want to optimize my F1 scores. And it is hard thinking about socio-technical constraint analysis, because that's what it comes down to. So where are these things applied? At every level of the HR and recruiting spectrum, from sourcing and talent discovery. Even if you know that you have an applicant tracking system, you might think that you're not using the AI features, but candidates sort of just pop up in the inbox, and they didn't necessarily apply to your job. They've just been put there by the system who's selling itself on its brand new AI features. That's pretty common. There's also some AI-powered functionality, which these systems rightly or wrongly claim as ethical. Now, I think it's good to have anonymization technology. It can detect your PII, your protected characteristics, your names, and your maybe photos and so on. This is generally good practice, as we'll see shortly. But it's not enough. It's not okay to just say we've removed their name, so now you can't tell what gender this person is. I'm going to say if they went to an all-boys school and that's in their CV, you can tell what gender they are. So anonymization is not enough, but it's not a bad idea. And these tools are using AI for that as well. And then for reviewing, passing, screening CVs or resumes, as they're called in the US, and then ranking, shortlisting. And there are so many more applications of AI. So let's go back in time and think about, okay, but is this really a problem? What is fairness? And where did it come from? Why do we even talk about this? So a little primer on labor laws, and we're going to focus on the US here. So in 1950s, you got Duke Power. They're a power station, power company, and the Downriver Steam Station in North Carolina. If there's anyone in North Carolina in tonight, then you are living in the state, which is sort of the hallmark of one of the first ever labor disputes and labor laws as a result. So a sort of claim to fame. And so Duke Power was restricting black employees to its labor department. That was the department offering the lowest paying jobs. Now, what happened? A few years later, they mandated that a high school diploma was required for employment in other departments. So they weren't explicitly restricting their black employees, but those were the employees that probably didn't have a high school diploma. So they found a little way to have the same outcome, but it looked a little bit better on paper. And then in 1965, the Civil Rights Act of 1964 takes effect. And on that very same day, Duke Power complied with the act by adding an aptitude test and an IQ test. Again, sounds good on paper. Is that fair for everybody? It's the same standards that everyone is being held to. And yet they designed this approach explicitly because they knew it would disproportionately disadvantage Black employees. And so as a result of that, and it took, in the slow wheels of legal progress, it took until 1971, but the Supreme Court ruled in favor of Griggs. So they ruled against Duke power, and they established this thing that we'll be talking about a whole bunch today called the disparate impact doctrine. Now, they decided that the employment practices, even if they were not intentionally discriminatory, because it's very hard to prove intent. There's a lot of legal cases going through the US and in the UK at the highest levels of politics where it all rests on intent, and intent is very hard to prove in many legal situations. So you don't have to be able to demonstrate someone was intentionally discriminatory. They are still illegal. This is in the US, remember, only. They're still illegal if they disproportionately affect minorities and are not directly related to job performance. So if that aptitude test that Duke Power put in place isn't actually related to the job performance of the jobs that these Black employees are being blocked from because they haven't had the same background and educational opportunities, then if the effect of all of this is that there is a disproportionate effect, the disparate impact, then that is still illegal. And therefore, it places the burden of proof on employers to justify any such practices. They're still allowed to have these practices, but they have to be justifiable. And the landmark ruling is commemorated in North Carolina today. So if we roll forward a little bit in our history of AI scandals, I'm curious to know, I'm not seeing much in terms of chat, although hello to those dialing from Canada and Texas. But thinking just to yourself, like, do you know where the first AI scandal was? Do you know when it was? And I'm going to give maybe just a few seconds in case someone wants to snipe in here to demonstrate your amazing knowledge. Question marks. Okay, we don't know. At least one person doesn't know. Define AI. Good. Very, very topical question. So I think what this scandal counts as is what most people would agree is AI. It's a text classifier. It's using a tree-based algorithm as well, using a sort of TF-IDF vectorizer. So I think that just, if we talk about AI and machine learning is part of an AI system, then I think that's allowed. Tim gets 4 points. This is a story from 1979. It is in where I'm dialing in from today, London. So we hold the claim to the world's first AI hiring scandal. St. George's Hospital, in their wisdom, decided to implement a computer-based admissions system. So I'm not sure where PyData was in 1979. Should have got on that sooner, Jim and the team at NumFOCUS. But we're glad you're here now to share this amazing sort of educational opportunity so we can learn about good ethical practice. In 1979, I don't think they'd heard about any of that because they decided that what they wanted to do was replicate the decisions of the admissions staff. And that went okay, I guess, for a good 7 years until an investigation by internal staff revealed that the system has systematically discriminated against applicants with non-European names and also just all women, regardless of their qualifications. So it was, as far as, I guess, machine learning performance metrics go, pretty good. It was replicating the historical staff's decisions with 95% accuracy. Great, like pretty impressive for 1979. The downside is, you may have guessed it, that their historical staff decisions were maybe also quite discriminative. So this NLP system was able to learn all of that discrimination embedded in the training data it was given, held up its hand and said, I've nailed this, 95% accurate, and very, very discriminative, but also evidentiably discriminative. Now, in the UK, we have a thing called the Commission for Racial Equality, the CRE, now replaced by another organization, the Equality and Human Rights Commission, the EHRC. And they found that the system had unfairly rejected at least 60 applicants. So you could really demonstrate and prove it. This is, I'm going to say, a tick in the box for AI systems. It's kind of hard to prove that a human was being intentionally discriminative, But code and weights, you could interrogate them, you can stick them on the dock in a court of law, and you can really prove this stuff out. So that's, I think, a sort of positive angle for the future, because we actually do know that humans are wildly discriminative in general on all sorts of different protected characteristics. So maybe a bit of AI, if it can get over this hurdle of also being discriminative and learning those built-in biases in their training data, maybe AI is not such a bad thing. So what happened? You may be wondering, nothing in terms of economic punitive damages, no fines were levied. They offered places to 3 of the applicants they rejected. And the commission decided to at least shake up how hiring worked across the UK in the higher education sector. So they mandated that you have to now ask people about their race and ethnicity in the admissions forms. And it's a useful way. They can crunch the numbers and they can see in aggregate if there is discrimination occurring. So an improvement, a change to the best practice. Now, where do I get all these wonderful stories? There is something I think is a great resource. It's called the AI Incident Database. If someone wants to be proactive, I don't have the link to hand, but Google it, share it in the chat, and then you can help your fellow workshop attendees. But this is a really, really cool website. It's something that you see sort of new stuff coming out every day or every week at least. And it's pretty concerning, horrifying, interesting, maybe less stressful than some of the news, depending on which country you're in. But it's certainly, I think, a really important thing in this field, especially if this is the field that you're in terms of evidencing the other things that are happening. Now, why do I think it's so useful? Because instead of talking about theoretical threats with senior stakeholders and decision makers, because there's a lot of discussion out there, and I'm not saying that existential AI risks are not worth considering, but I do think that sometimes the conversations are too grounded in what people think might happen, or what they might worry might happen, or what sci-fi worries might happen, and not what's actually happening today. And the AI incident database is talking about all of the really bad AI things happening today that are definitely real. And maybe that might change the weighting and prioritization in some of the policymakers' minds or funders' minds. So there's some pretty bad things happening with deepfakes and disinformation, and also just bias and fairness is a pretty common thing to see here. So moving on, a little bit more of a recent story in our tale of AI fairness over time. A few years back, about 10 years ago, Amazon started testing a hiring algorithm. Well, fair enough, not the first, certainly not the last. But it did take them a good 4 years to decide it was maybe not a good idea. And I do have some questions about maybe why they decided to do what they did. So they got some bad news. It was reported as being sexist. It had to be scrapped. Now, I think this is where they went wrong. I don't think it's a bad idea to try and use AI for stuff, especially given the techniques we'll be covering today. But their outcome, their end goal was they wanted to be an engine where you give it 100 resumes, it spits out just the top 5. You just hire those. No human in the loop. Now, maybe this is maybe this is hearsay. It's at least quoted in the BBC, but maybe this is a bit of an exaggeration. I don't know. If you work at Amazon, if you know anything about this, do feel free to reach out privately to me. My email is somewhere in my profile. So I would love to know. But I mean, if you're in this sort of situation, human in the loop is a really good idea, at least in the early stages, and maybe continually from that point forwards to make sure that there's not just a completely automated decision-making process in terms of who's getting hired into your company and who's not, especially if that's discriminative or potentially discriminative. And in this case, it really was. Just the word woman was enough to drop someone down the list in terms of the rankings. So it was not gender neutral. There were other issues with it as well, but gender was the biggest spectrum of discrimination that was discussed in the reporting. So what is happening today? Just to wrap up our little history. In 2024, we've done some research into this. We've looked around, and we've seen that there's lots of different areas in the world of just hiring alone where the AI is being used. So there's a bunch of logos here, and again, some of these are wonderful tools and they're absolutely doing the right thing, and some of them maybe need a little bit more of doing the right thing. So again, if you work for any of these organizations or you know someone and you think maybe we can help them, put us in touch. But mostly the takeaway here is there's a lot of AI happening, and some of it is very advanced using LLMs. Some of it is more basic using regular expressions. Some of it's in the middle. And then some of it is even more advanced on top of that. So things like Pymetrics, which has now been acquired recently by Harvard for $200 million. This is a very big business. They also do video interviews. They do psychometric testing. And I think if you were to imagine what AI can kind of do, especially if you're really on top of the latest research papers, you'll know that you've got multimodal LLMs that are able to take in video footage, understand micro expressions, understand someone's maybe truthfulness or honesty, or whether they're lying or not in an interview scenario. And do we want that in our hiring tools? Maybe, maybe not. I don't know. It's a very cultural specific thing. But should it be fair, or should it be incredibly discriminative based on the color of your skin? I think that's fairly broadly agreed that that would be not a good way for this to develop technologically. But it's moving quickly. No matter what the regulators are doing, the technology is going to move forward, because if it saves time, then it's going to sell. Very simply put, and that's what we're hearing at the moment. So there's a little bit of background. Time to, at this point, begin to get into our first lab of the day. So we've got the link. I'm hoping the link is working now. I'll double check that in a moment as I swap my screen that I'll be sharing. But what you will see, and if you haven't done it yet, grab the link. There's a little requirements.txt. You can install all the packages, whatever system or dependency manager you like, and then you should get everything able to be up and running. If you use Poetry, then there's a Poetry lock in there as well. So I'll quickly switch over and just walk through what that should look like when you have this workshops code up in front of you. So let's swap over to over here. And we'll just double check that that is public as well. Okay, I'm seeing that on at least a private browsing window, so that should be good. So you can clone this, you can git clone it, or you can just download the zip. That will get you this folder locally. If you then spin up Jupyter Lab, then you should be able to see this interface. And what you want to do is load in, navigate to the notebooks folder, and then you want notebook1.ipynd. Now, there's a .py here. That's because I'm using a really cool tool called Jupytext, which helps me to do all sorts of cool things around version controlling my notebooks. Don't open the .py. You want the ipynd, the proper good notebook. But that's what that's about. If you're curious, Jupytext, very cool piece of kit. Bit out of scope for today's session, though. So load up number one. That's the only one we care about for now. And then as I go through this next section, then you can be following along with what I'm talking about. I'm going to talk about how we've actually created a data set here for experimenting with fairness in hiring. If anybody's getting any issues with this whatsoever, flag it in the chat, and I've got that over here so I can see that, and I'll help you out. But hopefully this is okay for you, and hopefully you're reasonably comfortable with command line. But again, broadly, if you've got something like Anaconda, then you should be able to get this up and running. And the command for spinning up Jupyter Lab is just Jupyter space lab. So Jupyter space lab should spin that up. So just make sure you download the zip, create your Python venv, for example, if you want to, or just Anaconda is also fine. And then you can pip install -r requirements.txt. Once that's finished installing Jupyter Lab, and you should be working. This is keyed into Python 3.12, I believe. So just if you've got a choice, it might work better on 3.12. Otherwise, you may struggle. There may be some version requirements that don't work quite well, especially with there's been all sorts of changes to the PEP build system since 3.12 came along. So that's caused a bit of chaos with some of the package installations. So hopefully this works. Hopefully you can get this up and running. If not, feel free to just watch and enjoy. I'll be running through every single cell myself as well. So following along now or later at your leisure. Okay, so if you are getting this running, you should be able to run these first cells and everything imports, and we're good to go. Another, I guess, caveat here is, again, you can just watch me. You don't need to join in for this bit, but this does require an OpenAI key. Again, it's not critical for the workshop. When we come into part 2, that's going to work fine for you, even if you don't run any of part 1. And I'll share the data sets that we generate in the chat for you all to play around with as well. So you don't have to run part 1. I'm not seeing any issues in the chat. So hopefully those who do want to follow along are okay. OpenAI API key, you can specify that if you know what you're doing with environment variables, or you can just type it in here. Obviously, I haven't done that because that would be leaking my OpenAI API key. Be wary about that as well. If you are typing it in and then you commit that to your GitHub publicly, then just be aware that you will have publicly released your OpenAI API key, and people can potentially then go and spend your money for you, which is not ideal. So just a word of warning, don't push sensitive keys to GitHub. If you do, just log into OpenAI settings and roll them. Okay. Public service announcement over. Back to what are we doing? So I'm going to walk through the high level of how we've generated a data set for testing fairness. This is actually a pretty big part of it. If you are working with an AI system, maybe it's your AI system, maybe it's your company's machine learning algorithm that processes potentially sensitive information, that it's got an opportunity for harm. These methods, by the way, they're not just limited to recruitment and hiring. They would apply just as well in financial applications, in healthcare applications, and so on. So these methodologies are fairly generic, but I will be sticking with that recruitment angle throughout today's session. So there's the code. Scan the QR code if you want, but otherwise that's in the chat. We'll move on. So how did we create a data set? Now, if you are testing fairness, you've got 2 options. You could potentially use a data set you already have, chock full of PII, protected information like names and emails and phone numbers, or you could create one synthetically. Now, there are actually lots of good reasons to go down the synthetic route. It allows you to do things like adversarial testing or counterfactual analysis as well, which is pretty cool. And we'll come on to that right at the end of this workshop, where that can be useful. I think if I was doing this, I would like to be able to do a little bit of both if we're doing one of our fairness audits with a client. But however, for a workshop, there is absolutely no way that I could get away with sharing a ton of real world CVs to PyData Global. I think the GDPR people in the UK would be pretty upset with me if I did that, especially given that the ICO, the Information Commissioner's Office, is sort of nominally engaged with the Fairness Challenge as well, and knows what we're up to. So they would definitely be upset. So we don't share real information. This is all completely synthetic. So let me walk you through how this has been created. As you can guess from that the OpenAI key, these have all been generated by OpenAI. Now, is there a potential that we're using AI to generate synthetic data that we're going to use to test AI? Absolutely, there is. And we'll come on to a really good example of where OpenAI is introducing its own biases into this synthetic data set. But by and large, it's actually pretty okay. And at the moment, we're not saying anything about who this person is. We're just saying, please generate a CV for a software engineer with lots of experience in the left-hand side, or a software engineer with just a few years of experience. We also say on the left-hand side, make the CV really good, really high quality. And on the right-hand side, we say, make the CV less good, less high quality. What I'm trying to get here is lots of examples of better quality CVs and lots of examples of lower quality CVs. If we throw that in front of a simpler machine learning system, it should be able to at least tell something about quality and experience as a result. So in this case, we're just going to focus on a simple example. It's going to be just a gender or sex-based analysis, women versus men. And we've actually got 100 CVs that I've generated for each one of those combinations. I think in the code that you've got, it's set to 12 CVs in total, just to make it pretty speedy to run through. But what I've done behind the scenes actually is I've generated a data set of 400. Feel free to set it to 400, and then it'll take maybe 30 minutes to run or so if you want to do that. Otherwise, I will upload the one that I made earlier when we get to that section. So 400 CVs, and it's dead even. We've got an even. Imagine this as an application to a hiring round. We're hiring a software engineer for PyData Global. Hooray. And we've got 200 men, 200 women have applied. So exact even. There's no bias in terms of the baseline rate of people applying. And there's also no bias between the number of quality women versus quality men CVs and low quality on both counts. Now, at this point, there is no way to indicate, other than the fact that I've just added a tag to say this one is woman, but in the CV itself, there's nothing that any machine learning or AI could use to infer that maybe it's a woman or maybe it's a man. So what we also do here, and this is a common technique in more traditional non-AI discrimination research, is you have these standardized CVs and then you inject clues. Sometimes the clue is a name, and we will do that as well. Although for the purposes of the fairly simple text classifier, it's not going to know what to do with unique names. It will just see them as boring, unique bits of information, and it will discard them. So we need to give it something else. And this is also fairly common in non-AI discrimination research, sort of the research in this field, and we'll see a little bit of it shortly. It spans several decades, and there is a very, very good pattern of how these things are done. Injecting clues is one of them. So in this case, again, I think if we were doing this, in fact, the work we are doing for the Department of Science, Innovation and Technology is much more focused on very carefully designed clues. We're not using AI to write our clues for the work we're doing that's research work, but I am using it today for this workshop because you get an idea and it's kind of fun. It also showcases how these GPT-generated clues reveal GPT's own internal biases, which is, again, the research work that we're doing at the moment. We're trying to really, really pin that down and see if we can measure it. So GPT seems to think, we've asked it, and you'll see the full prompt in the notebook. We've asked it to generate clues for male software engineers, and every CV gets a slightly different clue. They're generated one by one for each CV. And it's fairly generic. And realistically, I don't think there's anything here that I think is a strong clue that this is a man or a woman on either side. And I think the clues that ChatGPT thinks are obvious clues, and I do say make them really obvious. And so it's just gone with actively engages in STEM outreach programs aimed at encouraging young girls. And honestly, if ChatGPT thinks that that is a strong clue for a female software engineer, then we really, really need to figure this stuff out, because ChatGPT has got that real bias embedded in it. I'm pretty sure there's some people in the chat who are engaged in STEM outreach programs aimed at encouraging young girls. I'm sure there's some people who are dialed in today. Some of you have engaged in things like Django Girls. Some of you may have engaged with a program that I helped to set up many years ago called Humble Data, which is the same idea, free coding workshops at conferences aimed at underrepresented minorities in tech. It's not really a gender-specific thing, I don't think. I think to call it such is pretty contentious at the very least. So I think that could absolutely introduce problematic biases. However, for now, I'm going to let it do its thing, because as I found out, there really wasn't enough to go on with just these clues alone. So I do actually end up just adding the word woman on its own at the very bottom of every one of the women's CVs, just because the text classifier is kind of like, it's a pretty good, it's a light GBM model you'll see that we use in the part 2 notebook. It's a pretty advanced model. We're doing a pretty decent text classification, and it is so not advanced enough to actually pick up on these subtle clues. So if you're thinking those aren't great clues for men versus women, Light GBM would agree with you. So because Light GBM wasn't able to see any sort of difference between these, we actually just ended up putting in the most strong clue that I could, which is replicating that Amazon story a bit. Let's stick the word woman in and train a model that is really, really biased against women, and it knows which ones are the women because of that one word. But where does the bias actually come into the data set? Well, we've got to simulate a hiring round. So my recruiter simulator has, I mean, if this person existed at least in the UK or in the US, and they were caught doing this, then it would be very, very demonstrably illegal. This is illegal discrimination, very, very clear cut. If someone is saying, yeah, if you're a really good candidate and you're a man, you're basically through, 99% chance I'm going to put you through. But if you're an equally good candidate, but you happen to be a woman, there's a 1 in 3 chance you go through. If that person actually existed, then I think they would be fined pretty heavily, and maybe they wouldn't have their job for very long, and their company would also end up fairly swiftly in an employment tribunal, and it'd be pretty expensive. But I'm doing this on purpose. I am trying to create an extremely strong gender bias in our data for the purposes of just this workshop, but also it's the sort of thing we might do if we were testing an AI system. Okay, an AI system should be able to see this sort of data, train upon it, and then iron out all the bias. That's a really good machine learning model if you can do that. So if you've got an AI recruitment system, I don't care if I've made an awful synthetic data set here. I'm going to use it to test how good your AI system is at zeroing out the bias and yet maintaining as much of the differentiation in high versus low quality candidates. So there's another thing that we do, which is adding names, and this doesn't make that much difference for this part of the workshop, but you'll see we reuse this idea later. So this is actually using a published research data set. Thank you to the Bloomberg data team. We'll run through their amazing article where this came from in a little while. But they brought all this together. They helped share this on GitHub, made it very easy to find this data. It's not data you can find in the UK, but the US sensor data does allow you to identify distinct names identifiable with specific genders and racial ethnic groups, and find names that are really, really distinctive. So people who have a certain name combination are very, very statistically likely to belong to that particular gender and ethnicity. Again, this isn't particularly contentious in the world of discrimination research. This is a fairly standard technique, as you'll see. But I'm using it here to allocate names to the CVs because I just think it looks nicer. I now get a beautiful synthetically generated CV that looks like this for a completely made up person. I'm really terrified that there's someone actually, this person exists now in the audience. No, this should be completely made up by OpenAI, and the name is selected from a statistical census data. And you can see just in the bottom right there, I've also just added the word woman because that blob at the bottom is just not even close for the text classifiers to pick up on as gender-based discrimination. So, I mean, there's an interesting insight there. If you want to have machine learning algorithms that are not very good at discriminating, then all you've got to go on is the text or the way that people write, just use really old algorithms. That'll do the job. Don't use LLMs. Use the old algorithms because they're not smart enough. Although if you do obviously give them gender as a feature, then they'll use that. And if there is bias in the training data, they'll use it, and then they're going to be biased too. But as you'll see, we don't give it the metadata. We only give it the CV. So we're going to get it to simulate that hiring round. Okay. So some of you may have been following along in the notebook, but I'm just going to quickly run through that notebook for you so you can see how it all looks in code. And again, this isn't just something that I might do for a workshop. This is actually something that we would think very carefully. If we're doing a fairness or a bias audit or an algorithm audit for a client, then we're going to think really carefully about what data they have that we can use for testing, but also what is the synthetic data that we can really skew to see if it, when we throw it in as skewed data, is your system capable of handling it and unskewing it? So this is exactly the sort of process that we would go through when we're going through that algorithmic audit as well. Right, clear all the outputs, and let's start again from scratch. So I've got a data set size of 12 here. The one I made earlier has got 400. You'll see we've got our OpenAI key. We've got a beautiful function. Feel free to steal some of this code for whatever else you want to do with it. It's a fun little OpenAI library code that does some retries as well. Love a bit of retrying and logic and error handling. It also has got a nice prompt in it that tries to iron out some of the things that it does badly. Like OpenAI loves to tell me about how great its answer is, and you just have to say, like, please just give me the output in Markdown code. Don't give me your commentary. So we can load that in and we can say, give me a CV at a high quality, and it will do that. This is someone who's going to be 8 to 15 years, top tier software engineer. The CV should be well written. And if it's low quality, then it'll be 1 to 3 years experience. So here is a freshly generated high quality CV, theoretically for a generic software engineer who's got all the skills under the sun, crikey. And a theoretically low quality, I say low quality, it's a more junior person with a simpler CV is maybe a better way of framing that. Okay, so they've got some internship experience. Maybe they're a junior, but they're not as experienced. So at least there is a quality differential that we're encoding into the data set. So we can generate a whole bunch of these. I'm now going to generate 6 lows, 6 highs, and we can then go on to the clues. And the clue generation is a very similar function. I probably could have abstracted some of this, but keeping it simple, got some retry logic, and it's just saying, write a concise professional paragraph that indicates they're a man or a woman as appropriately. Don't say it directly. And that's all it is. And so we can generate these clues, and we can generate 6 for the men, 6 for the women. Then we go through our recruitment simulation. Here is our very biased, very much illegal recruiter, and they're making these decisions based on whether you're a man or a woman. They're going to select you through at a higher or a lower rate. And just to notice here, if you're a woman with a sort of the less experience, there's literally no chance that you're going to get past this recruiter. They're a pretty difficult, unpleasant person. And then we've got the callback. Callback here, I don't mean an asynchronous callback. This is a call back to an interview. It's a standard term of art in discrimination analysis and research. Oh gosh, we've got some issues coming through here. Okay, apologies for errors. Let's just put that through at 6. We are potentially missing some code in this. So I'm just going to double check, maybe restore to a previous state. I think we've dropped some code somewhere. But we've got our men. We've got our women as well. Apologies for the code errors. We'll make sure that I fix that immediately after this session. But you'll be able to follow along with much of this. Meanwhile, I'm going to briefly just go to a version I made earlier. At least for the video. There we go. Yeah, it's dropped a bit of code. It's disappeared somewhere. Maybe I missed that as I was going past it. So at this point, we've got all 4 combinations equally represented, the men and the women. We've got our clues coming through. Maybe I did just skip over that as I was running through it. Maybe I deleted the code by accident. Someone tell me. Thank you, Tim, for the horror emoji. And at this point, we've got our data set. We've got the CVs. We've got the CVs with clues, and then we've got our callback. So it looks something like this at this point in time. And the callback's based on that bias recruiter. So these distributions, we've got 6 high quality, 6 low quality. In the larger data sets, it's 200 of each. And then same with the sex breakdown. And then the quality, sex, and callback breakdown, at this point, that's where the bias is going to creep in. So the name analysis, we can see the top men's names and the top women's names. This is from the Bloomberg data set that I mentioned earlier. I'll bring it back. Potentially my screen has stopped sharing. Thank you, team. And so with loading the names into our data set, which currently looks roughly like this, we then got the ability to add some race is added purely at random. That's just because of the data we're using has race sort of built into the data structure. So these names are allocated to races by, again, the census data is taken from. So that's why we're adding race there. And then as a result, we're able to then extract some names from that data set. And so we're going to have the race allocated at random. These names then allocated, but they match the gender. They're mostly just for me to have a nice, beautiful CV at this point. And if I was to just say, "Okay, show me one of the high quality women," then it loads that up for me, and I can see their CV as well. I could do something with that. So at this point, we're going to export it to CSV because everyone loves CSV, but feather format because I love feather format. And at this point, we are done with this notebook, and we'll be coming back to notebook number 2 shortly. But I'm quite keen to share that file that we generated because you're not going to have that in the Git repo. Okay, so that's going to be available. Oh, wow, the little upload thing doesn't support feather format files. Okay, I've uploaded it as a txt file. Potentially you can download that, rename it to .feather, and I hope that works. That should be appearing in your resources any moment now. So you've got the code link, you've got this thing, resumes.txt. You're going to have to rename that to a feather formatted file in order for that to work. Limitations on the Airmeet Cloud platform. Okay. So we've got a nice model in the workings here. Let's go back to our code and we're going to load up notebook number 2. Okay. So notebook number 2. I'm going to make sure I don't skip past any of these little hidden sections as well this time. So at this point, we're going to load in our the model, the data set that we've just trained. I'm going to do a little bit of basic scikit-learn. I'm not going to spend too much time on the scikit-learn. That's not really the interesting stuff that's happening here. It's a very traditional scikit-learn sort of code base and pipeline. So the CVs, I am cleaning them up using cleaning code. And then we're going to read in resumes.feather. Again, if you didn't rename it, just change that to .txt for the one that you've downloaded. That should read in, and it should look something like this: 400 rows, and it's got those 8 columns. Now, we're only going to use the text column. We're not going to let the machine learning algorithm know anything else. So x equals df text, and then y is just the callback. That's our target. So we're framing a simple sort of scikit-learn pipeline here. This is a text classification pipeline. So I'm going to take that df text, which currently looks like this. It's just one column with the entire CV, just cleaned up lowercase, removal of punctuation. And I'm going to run it through a count vectorizer, which is going to tell me how many of the most popular words are appearing in each CV. So in CV position 1, the number 2021 is appearing 4 times. So it's a very simple vectorizer, bag of words vectorization approach being applied here. Now, the baseline callback rate, our target is 41%. So our very biased recruiter is calling back 41% of all of the applicants for the next stage interview. So let's just get our head around this. How is this data set now behaving? This is kind of cool. We made an entire synthetic set of CVs using OpenAI. We've text vectorized it. Does that have any sort of predictability? And the answer is, well, let's add a little semicolon there. The answer is yes. We can train a decision tree classifier on it. We can interpret it. It's picked up on because I've added that single word woman. If you don't add woman, it doesn't do this at all, and it doesn't know how to discriminate either. But with that women word encoded in the CVs, it picks up on it as part of the text vectorization, and it realizes, oh yeah, this is a great feature to use. I'm going to use that as my #1 feature because obviously whoever creates this training data hated women, or at least was very discriminative against them. So it's using that as its top feature. And then beyond that, it's words that are mostly aligned with sort of things you might expect being associated with a more senior versus a less senior person. So if you see blue, these are the code paths or the decision tree leaf nodes that are associated with quote unquote the people who were historically selected for in the training data. So people who are software architects, for example, people who talked about improvement opportunities and so on, agile methodology. I'm glad to see that gets an upweighting. If that gets talked about 3 or more times, apparently that's a useful predictor. The reason I say that is my last talk for PyData Global was a good few years ago, and it was all about agile methodologies for machine learning. Go check that out on YouTube. So what's the baseline selection rate across men versus women? And we can see, I mean, we know that the recruiter was very discriminative. We made them that way, but we can also see now in the sort of this data set that absolutely the selection rate for men is 70% and women is more at 10%. If we wanted to look at that differential for given keywords, we can do that as well. So men who mention the word AWS at least once get selected almost 100% of the time. Men who do not still get selected about 40% of the time. Women who mention AWS getting selected 30% of the time. So probably very, very related to the higher quality, more experienced people. So let's actually find a decent model. Decision tree is not usually the best model. So quick model selection process. We're doing model selection, cross-val score, accuracy, 5-fold cross-validation. Very simple piece of code. It just says the dummy classifier, your baseline is about 59%. That's also the baseline selection rate in the data. So what about a random forest? That gets 77% on the cross-validated accuracy. The decision tree 79, so it's not that bad. A shorter decision tree, even better. But actually, the one we're going to go with today is this one, which just pips it to post our light GBM classifier with some settings that I came up with earlier. So this is the model we're going to use. And we're going to interpret this using this thing, permutation importance. Again, a topic for another day. If you're interested in this, it's just a very nice feature importance technique that's built in to scikit-learn. And we can get an understanding. We know the decision tree was prioritizing women, but what is this LGBM classifier prioritizing? And again, women, architect, developing microservices architecture. I don't know which way that skews. Maybe that's a good thing. Maybe that's a bad thing, but it certainly is important to the model. And we can even go down to the raw data again. Which way does architecture skew? And actually, mentioning architecture is usually a good thing whether you're a man or a woman. But again, you've got that sex-based bias built in. Okay. Feel free to run this next bit. It's only one line of code. We might as well run it while we're here. I will explain what we're doing with that file, which is going to be stuck into your data/output folder in a little while. But back to some theory, because we're ready to start thinking about fairness metrics. Okay, so defining fairness. And I see there's a question about technical impossibilities. We're going to see a bit about those as well. So fairness, very, very controversial topic, generally. And often you'll hear about people talking about what do we mean by fairness? Is it fairness of equality, fairness of equity? And these are different things, and you may have a reason to use one over the other in your AI systems. This is why we talk about this as a socio-technical problem. This is not a technical problem to be solved with technology alone. You really have to think about who are the people using your system. If your AI is biased one way, who does it help? Who does it harm? If it's biased the other way, who does it help? Who does it harm? If you start offering loans to people when they shouldn't have them, then people are going to potentially default on those loans. That's going to really hurt their future credit rating. If you don't offer them the loan when actually they'd be okay to pay it back, then that's also bad. So you can sort of have harm whichever way you go. It's hard being a machine learning engineer in production systems. And then what are you trying to meet? Are you trying to give everyone equality of outcomes, or is it equality of opportunity? Difficult things. These are difficult conversations. And then when we start talking about metrics, oh my lord, there are so many metrics out there that you could be using. And if you've seen this confusion matrix before, a lot of these come into play in fairness analysis as well. Because what is a fairness metric? It is just one of these metrics, but then applied at the subgroup level. What is the, for example, the precision for men? What is the precision for women? Or if you're looking at ethnicity breakdowns, what is the precision or the recall for black versus white versus Asian versus Hispanic in a US context, for example? And if these are wildly different, then maybe you've got a problem. That's sort of the high level way of how we do this. So let's give you some examples to hang on to. There's a very famous case study called the Compass case study, ProPublica. Had a huge investigation, made a lot of news a few years ago. If you're not sure what recidivism means, it means reoffending. If you're a criminal, you break the law, and then you reoffend later after you've already been caught and punished in some way, often with prison time. So the rate of recidivism in the USA is 70% within 5 years of release. That's I guess, somewhat high number, perhaps, and that's why people thought, can we do something about this? So what they did is they tried to predict someone's likelihood of recidivism based on loads of data points about that person. Now they removed some of the protected characteristics. So they removed your ethnicity, for example, but they kept in where you live. And where you live in many parts of the UK is heavily correlated with ethnicity. So if they left in zip code, you can basically tell someone's ethnicity. And it started using that in pretty bad ways. So I'm not going to go too deep into this particular story. It's a good read. It's quite detailed. There's a lot to sink your teeth into. But I do recommend it if you're interested in this. So more importantly for what we're learning now, what are 3 metrics? And how do we choose which is the metric to look at? So false positive rate. Okay, in a reoffending case, these are the people who are not going to reoffend. Okay, these are people who would have been rehabilitated, but your model has now predicted they're going to reoffend. And we're using an AI system here because we're trying to reduce recidivism by locking people up for longer if we think they're going to go and reoffend. That's sort of the idea behind that story. Can we use an AI to just keep people in prison if we know they're just going to come out and reoffend? But we've got harms. Okay, if they're not going to reoffend, then you're just locking people up needlessly. That's your false positive rate. If your false negative rate is high, that is the people who are going to reoffend and you thought they're not going to. You release them, they commit more crimes. So they're pushing up the recidivism because you've got some errors on that side. And then you've got your false discovery rate, which is similar to, I think, precision, but just sort of flipped the other way around, but the same harm. So for all the people who the model thinks, yes, you're gonna reoffend, how many don't or wouldn't? So we can see the Compass study, we can see those fairness metrics, we can see that actually 2 of these, the FPR and the FNR, are pretty different. The algorithm was twice as likely to be locking up black people who weren't going to reoffend. And it was twice as likely at letting the Caucasian people go who were going to reoffend. This is pretty bad. Like, in terms of societal harms, this is not great, which is why it became a big story. It's also worth noting this is a much smaller difference here. And the creator of the algorithm in a court of law said, yes, but on our fairness metric, we're actually fine. This is the correct measure and it's okay. So who's right? And why can't we just have all of the measures of fairness be considered in the round? And that's because that's mathematically incompatible, a little bit as Kamal has indicated in the chat as well. Why? A little bit of maths for you. If you want to take my word for it, you can zone out for 30 seconds. But in short, you've got your false positive rate, which is defined as prevalence multiplied by false discovery rate multiplied by false negative rate, which means if you have unequal prevalence and your FDR is equal, then you can't have FPR also be equal as well. You can have the false positive rate or the false negative rate be equal across groups, but not both, because these things multiply out. If you need a little bit of time to take that away and have a think about it, then take a screenshot. But the maths is sound. So in short, key takeaway, it's mathematically impossible to just say, let's use all the fairness definitions, because one thing goes up, the other thing goes down. As the underlying weightings of the population changes, then again, these things are very difficult to settle. There are a few other fairness metrics out there, and I would be remiss to not mention them. We also use them in some of our other modeling analysis. So demographic parity. This is kind of what we're talking about here. It's a generic term for choose your metric of interest that should be equal across your different groups. So your false positive rate should be equal, or your false negative rate should be the same between your African American versus Caucasian people, or men versus women. But that has a drawback, which if there are individual differences in the population, then blindly equalizing these, forcing your AI systems to have exact parity, is unfair in a different way. We're back to that equality of opportunity versus outcome conversation. So that's worth understanding. Are the fundamental differences in the population genuinely real in a way that just forcing them to be equal would then cause unfairness in a different direction? And again, this is politically tricky. I'm not going to give you answers to the politics of all of this. Many countries are going round and round about things like positive discrimination and so on. But that is the potential downside of forcing demographic parity. Another one which I think is pretty cool, we'll show you how we've used this in our current research, is this thing called counterfactual fairness. In short, if I throw a CV into a system, and then all I do is I change the name from a white man's name to an Asian woman's name, then the model really shouldn't be changing its decision if their entire experience and job experience is the same. So if everything else is kept the same, but we change that one protected characteristic, and the AI suddenly says, aha, that is an Asian woman's name, I'm going to put them at the bottom of the queue, we've got a problematic model. So we'll see how we can really use that in practice towards the end of this session. The different way of measuring fairness. And then we've got this thing called equality of odds, which states that the chance of false positives and true positive rates for individuals should be equal, at least the people. So the people who do reoffend, for example, they have a true positive, then the probability of rates for those groups should be equal. It's a very wordy way of saying equality of opportunity. You only need to look at true positive rate, and basically it rewards models that really agree with the ground truth. But that's okay if your ground truth is fair. If you've done lots of work to really neutralize your training data and you're sure that your ground truth is unbiased, then maybe equality of odds is a good thing to look at. In the example we've given here, we know that the ground truth is very, very biased. We've got that pretty unpleasant recruiter who's made those gender biased decisions. And so therefore, equality of odds would be problematic to use as a fairness metric in this example. There are more metrics out there. This is where it gets a little bit overwhelming. And you might just think, can I just go back to just caring about F1 scores and that's all I have to worry about? But there is a really cool tool. It's called Aequitas, and it's one of our main tools that we're talking about today. And they've actually got this really cool website and this thing called a fairness tree, where they can help you to decide which metrics are right for your socio-technical problem. So depending on the questions, you can sort of follow it through, and it might help guide you to have good conversations with people about the right kind of metrics. So we're going to actually use their toolkit now. This is the Aequitas website. You can grab it from here. I'll pop this link in the chat as well. So you can follow along if you would like to follow along with me. If you have followed along in the code, then you'll have that Aequitas CSV. Otherwise, you'll see me go through this process. So I'm going to go along to their toolkit. I'm going to use the website hosted version. Now you can pip install this. Just word of warning, your mileage may vary. It's a few months out of date. It doesn't work well with Python 3.12 or any operating system that isn't that isn't Windows, as far as I can tell. So it is tricky to get up and running, but that's I'm sure going to be solved in just a few months' time, maybe with a few updates behind the scenes. But word of warning, if you are trying to run this, and it certainly won't install into the same repo as Fairlearn because they use different versions of pinned NumPys under the hood. But the website version works great. Just worth knowing you can run this locally if you have sensitive data, because it's a pretty cool toolkit. So let's see how it works. I'm going to stop sharing. I'm going to load up the website. So just to check, where did the data that I'm about to load come from? It's actually just the data that I've got here. I've extracted just the ground truth labels, the predicted scores from our LGBM machine learning algorithm, the trained one, and then I've also brought in our single protected characteristic we care about. So Aequitas is kind of interesting. It doesn't care about your raw data. It doesn't care about your model. It doesn't need to analyze your model or anything. It just needs the outputs, and it needs the ground truth. So this is useful to think about. Maybe you're in a company where you don't have access to the model, but you do have access to this information, in which case you can use Aequitas. However, if you're in a situation where you don't have ground truth, then you cannot use Aequitas. You have to use one of the other techniques I'll talk about shortly. So how does it look? Let's give it a go. So this is the Aequitas toolkit. I'm going to go to the upload page, upload our file, Aequitas CSV. And then I'm going to select the majority group as the default, and I'm going to keep the protect characteristic checked. And it's going to compute all of these metrics under the sun for me. I'll just go with the default fairness report. And now, in an instant, they've done a full fairness audit on my machine learning algorithm's outcomes. And it's giving me a nice summary saying that this has failed every single one of the metrics, which is unsurprising because it's a machine learning model that's encoded all of the biases of the training data. And this is really nice because it's going to explain to you, what is this metric? When does it matter? Because they don't always matter. In fact, only a few of them are really going to matter to you and your company. So you're going to have a really good chat with your team if you're using this, decide which ones are right for you. Think through the harms as well. Who's been harmed based on, again, false positives versus false negatives in either direction. So it helps us to understand what these metrics are, if we should really care about them, and then what actually was found in our data. And it says, okay, in this case, women were, we saw a disparate disparity of women versus men at this level, 0.08x. And we can see that across a variety of the other metrics as well. And we can see what those numbers are. So on false negatives, it looks pretty bad. Now, what's a false negative in our situation? Again, we have to relate it back to your problem. In our problem, we know that a false negative will be someone who was missed over. So the woman should have got the job. They were skipped over, which is unsurprising if you think of it that way, that women have a 7 times higher false negative rate in our data set than men. Because that's sort of what the ground truth data says as well, is equally good women who have really high quality CVs don't get selected as often. But the machine learning model has encoded that, and it's the machine learning model's predictions that this is now looking at. So really cool little audit report, a really cool tool. It also has a Python interface, so you can actually build all of these functions and these calculations directly into a dashboard if you want, or into a data pipeline or an MLOps pipeline. Just take the Python part of the Aequitas library and use it directly rather than their interactive report. Okay. So now we know something about fairness metrics. Now, how discriminative is discriminative enough to be illegal or unlawful? And again, this is very much jurisdiction dependent. In the US, there is a thing called the 4/5 rule. It says if your disparate impact is sort of below 80%, so that's 7x is definitely below 80%. That's more like 14%, so well under the 80% limit. Then that you basically would be deemed illegal by the EEOC, the Equal Employment Opportunity Commission. In the UK, things are different, and again, in your country, there will be different legislation. And this legislation is not sort of AI updated. These are active conversations that are ongoing. So on to our next lab. We're going to learn how to now mitigate that fairness. There's a wonderful library called Fairlearn. So back to that part 2 notebook for those following along. We'll see how this amazing piece of kit works. So we're into section 3 now, the intro to Fairlearn. And again, I've added lots of information into the notebook, so you can take this away, you can run through it in your own time if you want to, and it sort of stands on its own two legs. So Fairlearn's got a lot of these metrics built into it, so we're going to use those directly. Some of the metrics we're using actually were built into scikit-learn, but FNR, FPR, equalized odds difference, which I'll talk about, these we can import from Fairlearn, and then I'll talk about these very shortly. So it's a package. It does quite a lot of things. I'm going to demonstrate a sort of a small chunk of its functionality, but it's got lots of fairness metrics, and it's got lots of different algorithms and approaches for mitigating unfairness. And I'm going to just show you 2 of those today. So the core part of Fairlearn is the metric frame. This is open source, by the way. Google it, Fairlearn, on GitHub. So the core part of this is the metric frame, and it's a way of just bringing in lots of overall metrics, but they have sort of the within group and overall group built into it. So it's just a slightly fancy data frame with a few extra methods. Now, one thing it needs is the protected characteristic encoded, ready to go as a category variable in pandas. So that's what we've done here. Again, this is 50-50, men versus women. I've got 400 rows, and my callback rate is 41%. I'm going to set up a bit of a train test split here, and we've also got the same split for the protected characteristic column. So now in my training data, I've got 260 rows, and my test data, 140 rows of discriminative outcomes. So let's train our model to become a biased, unfair model, and generate some predictions for that model for the test data. So the model hasn't seen the test data. It's not overfitting to it, hopefully. These are the sort of genuine predictions, which we're now going to analyze. I'm going to collect all of my favorite fairness metrics into one dictionary. So we're going to look at the balance actually. This is, I could just say accuracy, but it's slightly unbalanced. This is more useful when you have really unbalanced data, like sort of 1% callback rates. This is even more important. But just think of this as the performance. So if this is really high, our model is very good at replicating the training data. False positive rate, if that's high for a given group, that means our model is inviting people to interview who it probably shouldn't. And if the false negative rate is high for a group, it means the model is skipping over really good candidates, potentially unfairly. But the unfairness is a group comparison. It's not just the metric alone. So we load in all the bits of information, our ground labels, our predictions, our sensitive features, and the metrics we want it to analyze. And Fairlearn calculates that all, brings it together in this metric frame, which we can then analyze. And there are sort of 3 little bits of analysis I want to know. Number 1, overall. Across the entire set of data, my accuracy is about 81% with this model. The false positive rate is about 6%. The false negative rate is 32%. So I'm inviting a few people to interview that I shouldn't overall, and I'm skipping over quite a few people that I probably should bring to interview. But what about the group level breakdown? And this is where we see, unsurprisingly, there are some differences. Now, at least in the UK, it's getting on in the evening. This is a lot of numbers to be looking at, so let's just look at that visually. So the same information, but visually, and we can see that the balanced accuracy shows that actually we are quite good at replicating the training data, but we're much more accurate for men than we are for women. The false positive rate is higher for men than it is for women, and the false negative rate is higher for women than it is for men. What does that mean? We're inviting men to interview who are underqualified, and we're skipping over women on the greens here that should be coming into our interview process. So we've got harm being caused to men who are just being, we're wasting their time. They're not going to get through the interview process. We shouldn't have invited them. And on this side, there's great candidates that we're skipping over because of our gender bias. Now, for fairness, we want to know what is the difference. What is the difference between A and B, each into those groups? So that's the dot difference, shows us just the differences. And if I wanted to have 2 numbers to pin all of my hopes and dreams on, it is the accuracy. This is actually the same number we saw earlier, 81% overall. So this is how good my model is. If I get that higher, then maybe our company makes more money. If that's 50%, then it's a useless model. And a fairness metric. And equalized odds is simply the largest of these 2 numbers. Why do we call it equalized odds? Well, if we think of these as odds, so to speak, we want to bring both of them down. So if we bring down just false negative rate, false positive rate will pop up instead. Remember, there's this mathematical relationship where as one goes down, the other might pop up. So I want to bring both down. Equalized odds is basically the maximum of A and B. Therefore, if I want to bring down this thing, it's going to force them both to come down together. So a really, really cool little invention, this equalized odds fairness metric. So let's learn how we can mitigate. There are some cool tools built into Fairlearn that we can throw our model into, we can throw the data into, and it can maybe improve this situation. So the first one I'm going to walk you through is a thing called the threshold optimizer. This takes an existing chain model and it transforms its outputs. So it's an output-based post-processing technique. I don't have time to go into sort of the inner workings of this. I recommend there's a little summary here, or otherwise dig into Fairlearn. These things are pretty funky under the hood. Just think of it as we take the outputs from the model, we're able to post-process them, and just say, yeah, actually, maybe we shouldn't invite that person for interview, or we know that they're a man, and we over-select on them. Let's reduce them down a bit in various ways. So we say we want to reduce equalized odds, and it tries to do that, and we run that through a fit process, at which point we've got this thing which behaves just like any other scikit-learn model. We can fit, we can predict, and then we've got some new predictions. These predictions are looking like this now. So if you were building an AI system, you could throw the output to the AI system in a pipeline into your threshold optimizer, sort of jiggle around those predictions a bit, and then use those instead. That's sort of the idea here. So let's just repeat. This is the same code as you've seen before. We're going to collate our post-processing predictions, and we're going to see what the stats look like now. And by group, but I like the picture version, so I can see, okay, we've still got a discrepancy on accuracy. This looks less bad than it was. This still looks pretty bad. But overall, has the difference reduced? And I think before it was a pretty large, it was 78% equalized odds ratio. And now our equalized odds, the biggest difference is going to be this one here, 55. So we've definitely improved things somewhat. We've reduced the overall unfairness in the system just by doing some post-processing. Very cool. What else can we do? There is also a thing called reductions in Fairlearn. And again, this is a pretty complicated piece of kit. It's doing a sort of sequential reweighting your data set. If you think about XGBoost and the way that it works in terms of sequential data filtering and selection and optimization, then it checks how it's doing and it keeps on going over and over again. It's a recursive algorithm. Then it's sort of a little bit like that. I'm not going to go into the weeds. I just want to sort of talk through how we use this stuff and give you some functional code. So here's how we use it. We're going to give it an objective. I want to sort of reduce my error rate. Now we can actually add costed weightings here. If actually we don't care about false positives that much, but I really don't want to miss good people, then I can weight those appropriately with some costs. Then I want the equalized odds. That's the thing I've been looking at. And then I load in my exponential gradient. This is our reducer, our reduction. And at that point, just works like any other scikit-learn estimator. We fit it, we predict from it, we've got some predictions, we feed those predictions into our metric frame just as before. We can look at the within group predictions, but I don't like numbers, I like pictures, and I can see if that's improved things, if at all. And again, we've got a discrepancy. Is it better? Is it worse? Maybe you're already figuring it out by now. But again, what I really care about is how's that doing? I don't want the accuracy to drop too low. If it is 50%, then the model's so fair, it's useless. One of the fairest models you can have is just like a coin flip model. We don't want one of those. But is this number lower as well? And actually, it's come all the way down to 33. And I'm not even combining these approaches yet, but you could have a model that in the way that it trains and it predicts, it's increasing fairness. And also, in the way that it then processes that, it could bring that down even more. And these have got lots of little numbers and dials that you can play around with. Things like this number here, that's actually a hyperparameter. These are hyperparameters. There's more things inside this function. So you can actually really performance tune this stuff to try and get your accuracy as high as possible, but bringing down your fairness, reducing that bias as much as possible using the Fairlearn tools. And just like scikit-learn, this is only one of the options inside of Fairlearn. There's lots of others you can try. But to summarize this section, let's just do a bit of a comparison. We've got our three groups: the unmitigated raw LGBM model, the post-process model, and our reduced model. Now, again, this is too many numbers for me. So from a scoring point of view, we are losing performance. Our performance has dropped from 81% to 73%, but our fairness has also dropped down, or the unfairness has reduced. Now, again, I'm a visual person. If you haven't figured it out yet, there is a trade-off here. This is actually, again, a statistical relationship. There is a Pareto curve. This is well understood, that as your error reduces, as your model's performance improves, this is on this side, then your fairness goes the other way. So if we want to reduce our fairness, we get a worse model. And this it says error, it should say accuracy. That's terrible. This is accuracy on the bottom, inverted. So to the left is the best models, but they're the most unfair models. And on the right is the really, really good high performing models, but low performing models, but fairer models. So there's a sort of a key relationship here. And at this point, I'm going to start to wrap up with a little bit more insight into that relationship. Okay, so the fairness accuracy trade-off. It's a tricky thing. This is the Pareto front. If you are advising policymakers, or if you're advising your CTO, your CEO, your head of data science, this is the way that you can explain what you can realistically do for them. There is a Pareto front. And so this is well understood in the literature. There is always this Pareto front. And on one side, you've got models with very, very low unfairness. They're great models. They're very evenly distributed in terms of bias, but they have a high amount of error. They're not going to make your company a lot of money. On the other side, you've got models with very low error. They're really good at replicating their historical training data, which maybe is biased. Maybe that's why the bias is very high, or the unfairness is very high. So if you're in an organization that is just absolutely gunning it for machine learning performance, you might end up somewhere on the top left. But also that naturally and very mathematically means that you have the most unfair models. And this is something I'm concerned about. Without ways to do something about this, whether that's regulation, whether it's training sessions like this, then we're going to see a lot of companies out there optimizing their AI systems as much as possible for performance and revenue, which might also mean that the AI systems of the future will be the most possibly unfair systems that technology can create. That's my fear. Now, the opportunity is most models are not on the Pareto front. You're not that good at your jobs, maybe, and there's an opportunity to improve the model by reducing unfairness without reducing performance. And that's the direction that we can actually take. You can say to a CTO, yeah, we've got a piece of kit. It's not going to impact our performance at all. We're just going to drop it all the way down and find a post-processing technique or other things that will really, really draw down the unfairness. We're going to have better outcomes, fewer harms, and actually fewer harms probably means better for your business as well. It probably is miscalibrating your ML performance metrics to only care about performance against historical data without thinking about fairness. Fairness probably is going to help. In fact, a lot of the companies that we've spoken to in the HR space, the AI recruitment tools, they invest in algorithmic audits because it helps them sell more. They get to go to their customers. They say, we've been evaluated for AI fairness, and we've adapted our technology, and it is ethically approved. And it helps people to trust the system. It helps the sales. It's a great idea. So again, like if that helps you to sell doing this to your team, use that. Because I'm really worried that otherwise organizations just push you along the other direction and maintain our unfairness and minimize error. You can probably do both. So with that in mind, I'll share these slides to the same GitHub. If you want to see, there's some fun case studies here that I'm going to skip over around, like there are companies that definitely do not do the right thing and have been punished for it in the US. So this is sort of a recent story. But I'm running out of time, so you can have fun with these case studies. But just some closing thoughts. Number one, how bad is the harm at the moment? The harm is, I would say, low if AI-enhanced hiring tools are not commonplace. However, we've seen that they are quite common. There are a lot of them. This is big business. Some of them are billion-dollar unicorns, and more are coming on board every single month. Whether those tools are being used, the AI parts of it, I don't know. I can't tell that. But I think the harm is very high if those harms are encoded into the AI tools. And if they're not individual, they're systemic, they're hard to measure. Basically, this is really hard to see unless you're inside the company, you've got access to that training data. Now, one thing that I'd love to flag to you is if you follow me on LinkedIn, if you follow me on Twitter, I'll share some videos with how do you evaluate tools where you don't have ground truth trained data. Because Fairlearn, Aequitas, they all need the ground truth. But what about OpenAI? What about ChatGPT? How do you evaluate that? I've done another talk. It's on YouTube, all about that. So I'll share the link. You can find out how it's possible to evaluate tools where you do not have ground truth. And that's another form of external fairness or algorithmic audit that can be done. And it uses counterfactual analysis. The CVs we created, start changing the names. You throw it to OpenAI, you throw it to Claude, you throw it to Anthropic, you throw it to Llama 3.1. I can tell you some of those models are better than the others, and we cannot yet say which. We know the answer, but it's under embargo until May, so you'll have to check back in with me next year when the Department of Science, Innovation and Technology allows us to publicize our research. But until then, have a look at my LinkedIn or my Twitter, and you'll see the video of the methodology. So what can be done? I think yourself is actually one of the best tools that we have as a society, as humanity, to improve things. It's the machine learning developers doing the right thing. It's hopefully me giving you a few good arguments to persuade your company to invest in you doing the right thing. Doing the right thing often is pretty profitable. You can say, yeah, like you don't trust AI. Well, we've done some really cool things to try and do the right thing. Do you trust us yet? And you'll sell more stuff. But there is regulation coming down the road. We've got, actually, it's just been announced now, the AI Management Essentials in the UK. You've got the NIST AI Management Framework. You've also got the ISO standard 42001. So for the standards nerds in the room, there are things actually that are beginning to require this. And I think sort of 5-10 years down the line, ISO 42001 might become almost as common as ISO 27001 is now for cybersecurity. And it's very process-based. It's a very similar sort of ISO standard. Does anyone care? This is the research that was done by Bloomberg. They saw that ChatGPT selects Asian women almost twice or over twice as often as black men for an HR role. And they found similar patterns with other job roles and other combinations of gender and ethnicity. So really, really cool piece of work. And I'll again make sure that the link for that is in the chat shortly when we go into Q&A. But it's a pretty common thing. These models are discriminating. The LLMs are built into the most advanced tooling, and the LLMs are biased. They do select one group of people over another, and it's not always the same group of people. It's not always women over men. It depends on the role, and it depends on the ethnicity. And sometimes you throw age into the equation, and it turns out that all hell breaks loose, because actually the only thing that matters to some of these LLMs is age. And if you're too old, you're not getting the job. That's a terrifying world to be in. So the benefits of AI-powered recruitment is amazing if you've just had 1,000 CVs land in your inbox. The downsides are really insidious. They're hard to measure. So closing thoughts. Almost half of Americans say AI would do a better job at recruitment. Is that a good thing? I don't know. Maybe, maybe not. Depends how the AI is built. And you've got actually now 1 in 5 job seekers in the US have changed their names on a resume. And that's not even because of AI discrimination. That's human discrimination, which is entering these training data sets, which is only going to increase over time as the biased AI creates new training data. So it's a scary world out there. If this has been interesting to you, you can follow along with our journey. I said we've got some really absolute killer insights coming out over the next 3 to 6 months. We're going to be publishing them all on our little newsletter. There's only one every month or two, so it's not too common, but fairnesstales.com. We'll also be talking about any sort of latest news of things going wrong in the world. So feel free to grab that and sign up to hear more. Otherwise, thank you very much for your time. I think we're probably out of time for questions, but I imagine Jim's going to go and tell me that I can jump into the Discord and answer questions there. So that's exactly what I'm going to do. If you'd like a fairness audit for your company, do get in touch with us. My email is there. And there's actually 2 companies that we partnered hand in hand. So there's also Bays Consulting. If any of you are on the call, thank you very much for the amazing collaboration we've had so far. And into the future, we now have a combined fairness audit service that we're offering. And thank you also to our funders in the UK government and our partners in the regulators who are along with us for this absolute wild ride into a terrifying but hopefully increasingly positive future if we can all learn that doing the right thing is a really good idea. Thank you.